All right, while everyone is getting their last setup, getting out their machines, yeah, some of the seats don't face the stage, so you might want to. Tables are nice because they're communal, but every once in a while people can't see everything. So fortunately, we have lots of space. So, welcome everyone to the 2-in-1 part of the new contributor workshop. I'm going to say a couple things first. This is the first time that we're doing a new contributor workshop and breaking people up by prior open source experience level. We're still working out the details, so any feedback on what we do where is, we're definitely going to send out a feedback form at the end. What we're going to do in this session, if some of you have looked over the slides, you have seen there isn't a whole lot of detail. Most of this is going to be get your hands dirty. I will demo on my Mac OS environment. A lot of this should work similarly, if not the same, on a Linux environment. The Windows dev story is under construction. Again, lots of areas for participation. If that's your jam, there are so many opportunities for you. What we will start with in this session is I will give a very high-level overview of the Kubernetes Codebase. And then we are going to follow some of the most common development patterns. I will demo them in front of you. Things will break. I will mistype everything. So this is part of the session where you settle in and kind of get used to mob debugging. I hope it'll be fun. Another caveat that I will start with right away is nobody knows everything about Kubernetes. That includes me. I hopefully will be able to lead you on to areas, groups, and people who do know what you want to know. So it might happen that you ask a question and I can't tell you how or why that works or doesn't work. Hopefully, we'll discover things and solve things together. So we're going to start with the Kubernetes monolith. Monolith is word that gets thrown around a lot, and people have opinions about it being a good thing and a bad thing. It's a thing, and it's the thing that has organically grown for 5 years now, and we are, all of us, getting used to living with it. So what I'm going to do, I mentioned already, most SIGs are stakeholders in the core repository. In the community, we refer to Kubernetes as KK, because it feels silly to say Kubernetes. Funny story, so I work at GitHub, and so our core repository is github.com/github/github. So I no longer care I'm no longer bothered by saying Kubernetes. But if you ever see like K/K or people say KK, that's what they mean. They mean the core repository. So let's head there. And this is where I get out my notes. All right, so please raise your hand if you have questions. If you are confused, there are some gremlins in this repository. I told someone when I mentioned that someone gave me a Codebase walkthrough, And then I said, and it took 2 hours. And the answer was, that must have been really high level. Hopefully, we won't be sitting here for 2 hours with me talking about the Kubernetes code base. I just want to show you the general areas of where to find things. There's also the opportunity for you to ask code owners of specific areas later where you can find, if you have a really, really specific interest, it is better if you find a code owner of that area and ask them, hey, where does this specific thing live? Without further ado, let's get started. I am just going to walk down the folders in the core repository. You can follow along on your machines, or you can watch. If I go too fast, let me know. First folder, .github. This is really just about GitHub management. We have a pull request template and an issue template folder. Codebase has licenses and an owner's file. This is mostly to do with licensing. Why is this not fit on my screen? No. Oh, well. Let's keep. I am, but it should still fit. There we go. And then this is kind of the first folder that looks somewhat interesting, right? Oh, is this where the Kubernetes API is? Nope. This is actually just where we keep the specs for API schemes, API rules, and documentation on existing rule violations. This is not the Kubernetes API. Ooh, that's right. My microphone lives here now. The build folder. We will do things, or you may encounter things in the build folder that you are going to use to run your scripts. This is a bunch of tooling that is either going to be part of your workflow, or is part of someone else's script, or is part of a specific script in order, or gets referenced in a make file. A lot of that lives in build. Keep in mind, this is a community project that organically grew for 5 years. So everything that you have ever complained about in your company's internal monolith is also true here. Except it's public. The cluster folder. This is a little bit of a relic, having to do with different ways to provision clusters. You can see Juju, Kubernetes Anywhere, this GCE, this is cluster provisioning. A lot of that actually lives somewhere else these days. And if I'm lucky, I will remember where. The CMD, the command folder, CMD, this is actually one of the places where a lot of the top level stuff lives. So these are all the Kubernetes, this is where the Kubernetes binaries get built top level. So my favorite example, kubectl. I will forever say kubectl. Again, there's not much in this folder, but this is the main Go file where kubectl gets built. The actual code for kubectl lives in a different location that I will talk about in a minute. But this is where we exercise kubectl. Command, line 39, new default kubectl command. So you can kind of tell by the imports. That a lot of this code lives elsewhere. Some of these are a little bit interesting in the hyperkube folder, for example. If we look at main.go, This one, the new hypercube command actually implements all of the commands: API server controller, scheduler, kubectl, and kubelet. So if you're confused about what hypercube is, it's really a collection of commands. With that, later on, we are going to build one of these command binaries with our workflow. But for now, let's move on to top level. The docs folder. This one is left from when we actually made docs inside the Kubernetes core repo. We now have another sub-repository called docs. If anyone ever finds out what the difference between the hack folder and the build folder is, please let me know. In my mind, they serve the same purpose: hack, build. This is for tooling. This is for that script you need, or that script that was at some point useful. Again, I can only promise to walk you through it. I cannot. Actually, I'm going to encourage everyone to look around and find things that don't make sense and say, hey, we should clean this up, or can we fix this? Because this, just by going through this, you will find so many places where there's to-dos, where code can be cleaned up, and where old references can also be cleaned up. Logo. This has to do with Kubernetes logo things. Everyone knows what the steering wheel looks like. Ooh, actually, does anyone know why the steering wheel has 7 handles? I forgot to say that in the first hour. OK, so let's go ahead and see if we can see the logo. Can we do it? Will it open, or will it just? Oh my goodness, it's enormous. So maybe, anyway, everyone can look at, everyone can see lots of these. Here we are. The reason that the steering wheel has 7 spokes is because the original inspiration for Kubernetes was a Google project called Borg. Any Star Trek fans in here? Yeah, so this was named after the Borg from Star Trek. And then the open source version, the original open source version of Borg was renamed, completely restructured, renamed Kubernetes. But the reason the wheel has 7 spokes is because there is a character on Star Trek that is a Borg. And her name is 7 of 9, and that is why the wheel has 7 spokes. I am so glad that one person in this room is like, this is so exciting, because otherwise I would have been like, you all should watch some Star Trek. So trivia, that is the logo folder. Next, package. Package is another big one. This is where things get really, really interesting and confusing. Let's go back to the top level and look at the staging folder. I'm going to say this first, because this is one of the most confusing gotchas when you are programming with Kubernetes. Because Kubernetes is such a big monolith, there has been an ongoing effort to break up the monolith. This folder, Kubernetes/staging, is meant to be a place where code that can be separated out into more microservices-oriented services is supposed to live until we get rid of all the internal dependencies and the parts of the code can live by themselves. I personally got really confused by the name staging because to me staging is something that happens in CI. Forget everything you know about staging. This is the place where code lives before it gets separated out. It gets worse. We also have, let's see, where's the, here, SRC, there we go. Source, K8s.io. This should look really, really similar to the package folder that I showed you earlier. Actually, let me open another window. Oh, look, I wasn't staging already. Here we are. So here we see API, APIs, auth, capabilities. Let me break that up for you. Compare Kubernetes/package, Kubernetes/staging/source/K8s.io. Some of these look really similar, especially API, API server, kubelet. This is because a lot of the code that currently lives in package is on its way to staging, which is the prerequisite to become its own repository. And not only that, but if you look in the Kubernetes project, you will find, let's actually follow here. I am in the staging folder. I'm going to Client Go. Client Go is an excellent example. Who here has referenced Kubernetes/Client Go, the repository, when working and hacking with Kubernetes? I have. The actual code for Client Go lives in core Kubernetes. If you go, whoops. If you go to Kubernetes/Client Go, you will see the same code. Let me make this big again. What's up with that? It actually doesn't say in the top level README. It's pretty great. A lot of the tooling for Kubernetes lives in core Kubernetes and has mirrored repositories. There is a ton of automation that keeps these repos in sync, down to the name of the pull request in Kubernetes, right here, merge pull request, number 77,613. That's actually a Kubernetes pull request, and it has just been synced to this repo. When you want to write code in Client Go, you are going to do it here. Everyone with me so far? Hooray! I'm so glad I got this out of the way first. This is one of the most common gotchas when you're developing on Kubernetes. The really fun thing is that a lot of the imports in the code reference the mirror repositories, which, if you're familiar with Go, is usually, if it were in the same repository, it would be considered a circular dependency. But because it's in a mirror repository, it's not. It's really fun. I'm just a messenger, remember? All right. So the next gotcha is that there is roughly as much active code in Kubernetes/package as there is in Kubernetes/staging, and so on and so forth. And a lot of it is in the process of being moved. So if you're looking in the staging folder for kubectl, it's not there. It might be in the near future. So if ever you open Kubernetes and you're like, hey, where did kubectl go? It might have migrated. These are the two places where you would look. Whoops, no, not Client Go, sorry. The code for kube control, I'm just going to use both pronunciations interchangeably just to make everyone unhappy. The code for kube control lives in package. And you can go through, there's, let's see here, command, certificates, create. This will create a resource. And now the folders start looking like the kube control commands that you know. Okay, so where was I? I was in package. The next thing I'm going to talk about are the two API folders. You notice there is both API and APIs. Why? This is a historic reason. The original Kubernetes objects live in API. APIs happened later in the project when people grouped APIs together by logical connection. So let's take a quick look. Here you'll find pod, service, and resource. There's also persistent volumes in here. Interesting, really cool. At my work, we don't use cluster storage at all. Ooh. So sorry about that. I'll try to not point at myself, or anyone really. Whereas in APIs, you'll see a lot of the other more newer folders. So there's events, node, RBAC, scheduling. Next, there are actually, let's go ahead and look at, sure, let's look at events. E1, beta 1. I see. So here's register.go. This is actually, I believe, where the types are defined right here. Add known types, core.event, core.event list. This is for kubectl events, I believe, or cluster events. Oh no, it's an API machinery thing. Okay. Anyway, so if you look at the API or the APIs folder under any resource and look at register.go, that is where you will learn what type of resource this particular part of the API describes. So let's go back just for kicks to the staging folder. Nope, let me go that. And you will also see an API folder. And you will also see events. But you will not see registration. The difference between the two is that there's actually two different types. There are cluster internal types, and there are the external types. We have automation to keep both types in sync with each other. Most of you will never have to think about this, but this is why you will find similar looking things in two different locations. The cluster, the external API lives in the staging repo, and it has JSON tags. So I believe if I go here, register, and it actually has a types.go file as well. And you'll notice on line 31, or 29 right here, we actually add JSON tags so that we can use these types externally and with all sorts of plugin code. One more gotcha involving APIs. when you are looking for external APIs, you notice that the API folder looks a lot like the APIs folder from package. This is because of some naming convention and export history that I am sure I forgot. The external types from that used to be, whoopsies, I'm so sorry. I'm going to slow down 1 second. In package, the API folder is the original core Kubernetes objects. Then there were lots of API schemes, and those live in the APIs folder in package. The external API, which is mirrored and has JSON tags, lives in the staging repo under K8s.io. The API folder actually references the extended API, so the APIs folder in package, whereas actually right here, inside that, we also have core/v1, and this folder is where in package, those are the objects that live in the API folder. I am more than happy to go over this again, and I see a question.
So is one of them generated from the other?
They are both kept in sync. So most of the time, you will be wanting to change the external API types. Yes?
So I saw like some protocol files in there, like generated.proto.
Yes.
Is that what's used to generate things? Or
Yes.
Is that, okay.
Yes. Other way around? Protos are generated from the APIs.
And just in case when you generate a new proto, it changes, and like that's scary.
So the APIs are not generated from protocol files?
No, so proto came later. So originally it was just JSON. So we tag the Go files with information about what needs to be generated in proto. Okay. So yeah, it's kind of backwards. Okay.
Thank you so much.
Wondering where the YAML tags are. JSON is a subset of YAML. So all of the JSON tags are the YAML tags. So that's something to know as well.
Cool. In case, I'm going to repeat it in case no one heard this comment. I love this. I love this community effort of coming together and answering each other's questions. The comment was, if you're wondering where the YAML tags are, they are generated from the JSON tags because the two talk to each other in magical ways. Well, no, not magic, but you know. So in case you were wondering about YAML, that's where you would look. OK. Let's see. Let's regroup and go back to Kubernetes package folder just to kind of walk through what else is going on in here. Some of these are kind of self-explanatory. And some of these, I don't actually know entirely what they do, but here's the auth folder. This is for node authorization related things. Capabilities is actually, you can look at the code. It manages system level capabilities, so that's cool. Again, I encourage everyone to follow what looks interesting to them and read the code. This is meant to be a very, very top-level walkthrough. Client. This used to contain client code. It has a couple of leftovers, as does everything. So again, refactoring, cleanup, those are excellent opportunities for contribution. Cloud provider, you can already see migrate fake cloud provider to staging. A lot of this is in the process of being moved to the staging folder. The controller is another big, interesting one. This is where all the Kubernetes objects run. Cron job, daemon, deployment. This is real code. This is where you would contribute if you were to look at it. Deployment controller, you get the idea. Credential provider, excuse me. This one is something to help make it possible to have credentials from private repos. You can see AWS, Azure, GCP. Features. This has nothing to do with feature proposals. This is where you can gate features, which sometimes gets used. Kube features. Field path. I think that has something to do with tooling, generated. Let's look at that. Honestly, there's a, wow, this is cool, but I actually don't know very much about it. Kube API server. This is where a lot of the things for the API server to run. This is where we control admission of objects of resources into your cluster. We authenticate them and authorize them. When I say Kube API server, that is what used to be called the Kubernetes master. But this is what makes your cluster run. We already looked at kubectl. Kubelet, same idea. This is where the kubelet code lives. It runs all the code that's behind the kubelet. KubeMark is actually a virtual kubelet designed for testing. I already mentioned the old word for the API server. This is a leftover folder from when it was called the Kubernetes master. Printers. Ever wonder how your kubectl output looks really, really pretty? This is where that code lives. Proxy, kube proxy. Most of these, whoops, where did I go? I went back. Registry is another interesting one. This is where all the storage-related things live. So scheduling, storage, volume attachment. Again, it can be really confusing and difficult to find the correct place for what you're looking for. Some of these, again, are kind of self-explanatory. It's always useful to look into the utils folder, because a lot of the time you can find interesting helper details. Let's see. Start the API machinery repo. OK. The scheduler is in charge of scheduling pods. This is where that code lives. Security is security resources for pods. A lot of these, unfortunately, don't have a README, which is another area where we can improve. Security context, where's that? Did I just not go back? Why did I keep going? I promise I know how to use a computer. This is the service account logic, and you can tell that there's some work being done on Windows-related things. So that is the package folder. Let's go back to top level. Everyone still with me? Yes. Another interesting one is the plugins folder, because some of the resources that live here that you'd think were actually in the top level package live here. There's code for admission. If you see, always pull images. So when you are setting your pod to image pull policy, this is where that lives. Image pull policy always. This is where that happens. So some of those functionalities are plugins rather than top-level objects. Same with authorization. Does anyone else hear a hum in here? Yep. It's not loud enough to be an alarm, so did it just start? Oh, that makes sense. Very cool. Okay, I'm not worried then. We talked about the staging repo in concept. Things live in staging, source, K8s.io. And here are a lot of the other things that you might have been looking for in package that have already moved over. For example, the kubelet code. Config, v1 beta 1. A lot of this you can sometimes tell by when the last commit was, by how stable this particular part of the code is. Okay. Let's see, Kube Controller Manager. Oh, if anyone was wondering where all the rules for the staging repository live, they're in the publishing folder. Here are the rules for mirroring, branches, locations, and versions. So let's kind of quickly go through API extensions, API server, that's for custom resource definitions. API machinery, API server holds the logic for running, for how the Kubernetes API server works. Right here is the package folder, and there's a lot of that code as well. CLI runtime. This is where you find customize. Look at that. This is where customize gets added to the CLI, to kube control as a subcommand. And then we already looked at client Go. That is a thing that a lot of you are going to look at and deal with. This is what basically makes it possible for you to write. This is where you can get your Kubernetes client, query it, and do a lot of. This is where you. This is basically the code that you will use to interface with your Kubernetes cluster at home. You'll use the Go client. I already mentioned the cloud provider folder. This is where a lot of the cloud provider code lives. I'm not super familiar with it. Cluster bootstrap is pretty much what it says. This is cluster provisioning code. Code generator, I actually don't know. You'll notice that a lot of these folders have similar names and similar functions. That may be because they are used for different parts of the repository. I have seen a lot of instances where you can use, where we should really not have the same functionality in 3 different locations, but really just in one, and reference it. If you see any such instance, please contribute. Almost done, I promise. Component base. This is really nice. This is a plan to do exactly what I just said. We would love to be able to have some of these very common components in usage and tooling live in a core place so that we can all just reference the same tool and not write our own and have multiple different folders of this is where we generate code. CSI, container storage interface. Kube aggregator combines your regular and your extended API. So this is where you'd, if you want to do custom resource definitions, the Kube aggregator combines both APIs and presents it as a combined front so that your cluster really only has one API for your kubelet to talk to. The Kube Controller Manager is actually just a placeholder for when all the Kube Controller Manager stuff from package gets moved here. So again, you'll find similar names, similar functions. We already talked about some of these things. Let's go, I think metrics might be. Metrics. Metrics is about Kube internal metrics. And a lot of this is used for things like testing, benchmarking, related things. Let's go back. Package, command. I have. Node API. Let's go back. Oh, sorry, I went too far. There's a couple more things in here that might be interesting. Node API, so where the metrics folder is for metrics in the API server, Node API is actually for metrics for the nodes. So those two are actually really similar. You wouldn't be able to tell by the name, though. A sample API server these are actually really, the last 3 folders are actually some of the best folders in the entire repository. This is where you should start if you want to understand the API server, start here. There is a tutorial, there's descriptions, there's means of running it, and yeah, this is where you can get started and just really play around. And it's also really useful if you want to understand how the API server works in detail. Same thing if you want to write your own command line. So here's where you can go and learn how to write your own kubectl subcommands. It's pretty great. And a sample controller. And notice that all 3 of these folders were updated relatively recently. And I know it says 5 and 6 days, but that's when most people left for Kubecon. So, and same thing for controller. This repository implements a simple controller for watching resources This is where you can learn about custom resource definitions. If nothing else, I recommend that everyone bookmarks these folders and uses these as a reference. I almost skipped over these. I'm so, so glad I didn't. All right, back to top-level Kubernetes. We have a test folder, which is interesting. Most of the code that lives here actually is in support of testing. There's a couple of different kinds of tests. There are conformance tests, which interact with a virtual kubelet, and then there's end-to-end tests, which actually interact with a real cluster. Most of the code that lives here is to enable these processes. And again, you can go and get more in-depth information by looking at it, but we don't really have time to do all that in this workshop. Actually, one thing, here's test, and there are some utils. Nope, this does not look familiar. I'm sorry, I'm gonna go back. Here we are, test, command. So in test command, we actually have a lot of shell scripts, if you realize. And these are, again, what's used in testing. So these are helper scripts for testing all these different parts of any given cluster. And look at that. It actually has some documentation. Please keep the order of the source list alphabetical. Cool, almost there. Third party is similar to a vendor folder, and I think, I'm actually not sure why it's separate from a vendor folder. As of Kubernetes 1.15, we are using Go modules. However, Kubernetes always supports the past 3 versions, so the previous versions still using vendored imported Go code, which is why there is a vendor folder. This is also really, really fun when your code editor is not sure which version of Go you're using. So actually, the mailing list had some nice tips on that fairly recently. And then translations is really just how to add new languages to the documentation. Or if you want to write kubectl in a different language. And this is human languages, not computer languages. All right, cool. Do we have any questions so far? Because this is the end of the walkthrough, and I'm noticing everyone's getting really, really tired, and I've been talking for an hour. So I really hope that this has given people a nice overview of where to find things. If you want to have a slightly more people-oriented organization structure, I dropped you a link in the presentation to the sigs.yaml, which, what? That's fascinating. Why is this broken? Oh, because the link is broken. I'll fix it. Okay, hang on. git.kates.io/sigs.yaml. I'm so sorry. And again, community. And again, I'm really good in front of an audience. What the heck?
/ at the end again.
Is that what it is?
Or is it you need to go the master
Oh, that. OK, hold up. I'm just going to go to Kubernetes community, which works. And it's a top-level file. Where is it? SIG's YAML, there we are. Okay. So this is a YAML file, I know. However, if you want to look for a part of the Kubernetes code base and which SIG may or may not be in charge of it, this is not the be-all, end-all of this SIG is in charge of which code. However, if you are looking for Kubernetes, package, controller, namespace, you can tell from the YAML file that it is the subproject component base, which is a subproject of SIG API machinery. This is important for when you're contributing and you're looking for a reviewer and you're looking for collaborators. So this is another way of discovering locations in the Kubernetes core repository by area and by interest area. All right, I think we should all take a break and then come back and see if let's take a 10-minute break. We do have lunch at 1, but that's okay. So I want to see everyone back here at 12:20. Unless we have questions? Cool. You all need a break. Take 10. Testing. All right, I'm back. Very cool. It's been 10 minutes. Let's head back and go on. Yes, I took, so I want to fix this link. This is broken. I'm going to fix it later. So sorry. I took, what the heck? Why is this? Okay. I took an hour on this one slide. Don't worry. All the other ones are not going to take an hour. I hope. Okay. So the next thing I want to do together. If you have a Linux-ish environment on your computer, you can do this too. We can go build some binaries. First, we're going to go to the Kubernetes Developer Guide instructions. And for those who missed it, this lives in the Kubernetes community repository under Contributors, Devel, and it's Development MD. Here are a few useful steps to start developing on Kubernetes. I linked from the slides directly to a quick start. This is the general formula for building Kubernetes locally. So what we're going to do, what I'm going to do in front of you right now, and you can follow along and see if it works for you. If it doesn't work, you can ask for help, raise your hand, and maybe we can all figure it out together. We also have wonderful helpers over there, and you can ask them for help. But basically, if you want to build your own Kubernetes command, and we're going to use this example. And I'm going to make this a lot bigger, and I'm going to clear. OK. So this is the workflow that is recommended for hacking on Kubernetes. I'm going to go back and check out master. All right, first thing I'm going to do is I'm going to run git remote. This is the canonical way to set up your git remotes when you're working on Kubernetes. You are going to work off of your own fork. You are going to fork the core repository, and then you are going to clone your fork and call it origin. And then you are going to set an upstream remote called upstream. Please call your upstream remote upstream. There are, in fact, scripts that rely on your upstream remote being called upstream. Then this is my formula for keeping myself in sync with the Kubernetes master. I go git fetch upstream, and I'm going to wait. OK. Sweet. Then I'm going to rebase. I'm going to rebase the upstream master. So this is from Kubernetes, not Guinevere Sanger Kubernetes. I'm going to rebase it onto my local master. Then if I really, really want to, I can git push. I'm not going to do that because I have no idea what is happening with my own fork right now. But that would keep my own origin fork in sync with Kubernetes, with upstream Kubernetes. So now I know that I have the most latest version of Kubernetes on my local machine, which may or may not break this demo, by the way. We have a lot of pull requests that come in. There is a merge queue, a merge pool, in fact. And it can take a while, but there's a lot of changes every single day. Cool. Let's go back to the quick start. The way to build binaries is to use make. And the Kubernetes way to build parts of the code base so that you don't have to wait 45 minutes for everything to build is to give it a target. And the way that make targets work in Kubernetes is what? make what, all caps, equals, and then you choose the command directory the command package that you want to build. So CMD, as you remember, is a top-level folder in the Kubernetes repository. And kubectl is where the main.go for kubectl lives. So we are making, let's go back while my machine is doing that. Let's go back here. If everything checks out, you will have an executable in the _output/bin directory to play around with. And it's taking a while. That's okay. Is anyone else doing this on their machines as well? Very cool. Hopefully not too much trouble. Aha. Here we are, building Go targets. So what this will do is it will build you a local binary for your particular system, meaning that this will be compatible with whatever OS you're using. Now let's go ahead and check output/bin. Let me clear that so you all can see. And there we see kubectl. Let me actually just show that file, May 20th. That is totally today, 12/27. I just built kubectl. So now I should be able to use it, right? And here we are. That's the kubectl help text. Hooray! This is how you would build individual binaries. So if you're hacking on kubectl, you want to make it come out shiny colors, that's where you would do it. And then to test it, you would build on your own version. Keep in mind, let's see here. I'm going to see if I can make my terminal a little smaller so that I don't have to. There we are. That's the one. Sweet. Now everyone can still see. OK. Is anyone encountering trouble building this? Or is this working pretty much as advertised? Somebody's having trouble. Yay. Yeah. So is it Golang 12 versus 12.1?
Yeah, and Ubuntu's package managers are all I'm working on installing the extra Go version with GoGet.
Yeah. Yeah, so everyone's environment will look different. So it seems pretty obvious just have to update to that particular Go version. Interesting. I wonder. I thought that was fixed on master. So you might, yeah. If you have the most recent version of Kubernetes master, yeah, that can happen. Cool. But mostly success throughout the room? Nice. So the same kind of formula works for, let's say you're writing some code and you write tests for it, and you want to kind of see. I just want to run local tests. I don't want to run the entire test suite. I don't want to have to open a pull request to let the Kubernetes automation run my test suite just to tell me that I have a typo somewhere. That's really slow and also embarrassing. So let's break a test. Still on master, that's fine. Sure, that's fine. And I'm going to go and look for package. Let's not do it here. Let's use kubectl command y. So if you get down to the individual kubectl commands, you'll find Go files and you'll find Go test files. So let's see here. I'm just looking for a test that I can break. Let's see here. Constant. Maybe. This is not a test. Aha, here we are. Let's go ahead and change some of these test cases. Share first annotation, expect error true. Okay. Hello, Kubecon. So what I'm doing is I'm literally just changing a test object to show you what will happen if you run tests on this particular package. So we are running make test what? Let me go back to top level. Status. Okay, so here's the modified package. And the way to run tests on that package is make test rather than just make what. Let me check my presentation. Hello? No? Interesting. Did I just completely? Huh. Fun stuff. Okay. Cool. Make test what? This should work. Let's find out. All right, let me find my presentation. I think I accidentally closed it because I'm smart. While that builds. Is anyone else breaking their own tests? Please tell me. One person. I need to put dot slash. Did I break it? Yay. Nope, this works actually. So let's look at this output. Basically, there are some warnings may cause test failure, but here we are. We're running tests for API version v1 admission registration. This is running a lot of tests. So actually, no, never mind. Change it. You're right. I totally lied. But it tells you. That's awesome. That's actually much nicer than some other test scenarios. Okay, where are we? Here we are. Make test one. All right, so it says it's okay. That's really interesting. What did I change? Did I save it? Oh, we are expecting an error. Okay, maybe I shouldn't have changed that. Let's change something else. Annotations. Test parse annotations. Expect error. False. Annotations. expected. Aha. Let's do this. Let's break that one. Annotate test. And try it again. I just want to break a test. Aha. Yay, I broke a test. So basically, it's expecting the code that I changed right here. It's expecting to have 2 annotations. And I removed one of them. And the test shows we expected this, but we only got one of the annotations. So the tests work properly, and this is how you would basically test an individual package really, really quickly without having to test the entire code base, which is really helpful. Yes?
So these are unit tests, right? They're
Yes.
being run.
Yes.
So I'm wondering what is the thing that says like running tests for API version and then all those API versions? Are those?
Oh, thank you.
We good?
Yes.
Oh, we good?
I can hear you.
Thanks. So yeah, I was wondering. So these are unit tests that are running, right?
Yes.
So is there? I'm wondering like why it says like running tests for API version and then like a whole bunch of API versions. Are there like separate API tests, like functional API
Yeah.
tests? Or?
So let's. I have an answer too, but let's share answers. No, go ahead.
So in the API server, you can enable and disable different API groups and different API versions. So this is basically saying we're enabling a whole bunch of API groups and versions to be available during the test. And when you have an API server, you could decide, I just want to disable all of the app's API group and not make that available to your users. So basically this is saying these are all available.
So let's actually fix this back so that I don't. No. Ta-da, easy, get done. So now if I run tests on that package again, they should come out clean. And you can basically do this with any of the packages. Give it a test target, give it the folder, it will run the unit tests in that file. There are other ways to run tests, and there's other means of verification. The next thing that I'm going to show you is, let me remind myself. Okay. Next thing I'm going to talk about, and let's actually go ahead and do that up until lunch. What's up? So let's change direction a little bit and talk a little bit more about how the community organizes all of this. Has anyone here tried to file an issue or open a PR on any of the Kubernetes repositories? Yeah, quite a few of you, right? So what's the first thing that kind of happens? You get a barrage of automation right in your face, right? And the other thing that happens is you get told, oh, hey, you didn't sign the contributor license agreement. You can't do anything. Who here has not signed the contributor license agreement? Okay. So sometimes this is tricky because you don't know if you're, anyway, I'll talk about the contributor license agreement really quickly because there's a couple people here who haven't signed it. But basically what happens if you open a pull request or an issue in the Kubernetes community is a bunch of label automation will happen. And the reason I made this slide, which is small, actually, hang on. The reason I made this slide is because gathering all the labels can totally feel like gathering all the Pokemon, because there are so many and it is really confusing. Let's actually check out a pull request on Kubernetes. Oops. Here we are. Pull request. Even just looking at the pull request page, there are a lot of labels. You only need to know what some of them mean because a lot of them are automated. This is where the Kubernetes CI robot comes in, because this is the automation that will tell you what to do next upon opening a pull request. We have a couple of places in the community where we can practice a little bit of what happens when you open a pull request and what labels happen. Here's the ways that the community is a little bit different. If I look at this pull request, I can hover my mouse over the assignees and the reviewer's title, and nothing will happen. Even if I am the pull request author, I cannot use this functionality to assign reviewers and assignees. The reason for this is that even these functionalities are disabled because the project is so huge. It doesn't make sense for somebody who is really involved with the Kubernetes community repo to be able to manually change things in other parts of the code base. So we use bot commands for everything, for assigning reviewers. If you kind of scroll down here, nope, not on this one, but on a lot of pull requests, you'll be able to see that people use this kind of language. / kind API change, and notice there's a label called API change. / kind cleanup, and there's a label that says cleanup. And then / assign at Liget, and now you have an assignee, and Jordan will come, hopefully, once he sees it, and look at your pull request. A lot of these labels get added automatically, and a lot of them get added via bot commands. Bot commands, here we are. I have a slide that includes a link to all of the bot commands that are available. And some of them are really fun. So what we're going to do is head over to the contributor playground. Okay. So some of you may notice this is not a Kubernetes /subrepository. It's a Kubernetes SIGs subrepository. This is a different org on GitHub, but everyone who is a member of the Kubernetes organization is also automatically a member of Kubernetes SIGs. This is a little bit more of an experimental area. You'll find things like KubeSpray, Kustomize, KubeBuilder, Kind. This is all where a lot of the experimentation happens, and I actually encourage you to go look around here as well, because that's where a lot of the more recent, a lot of the younger, fresher efforts are happening. So there's a lot of opportunity for being with a project from the ground up. Let's go to the contributor playground, however. From your slides, head to the contributor playground, and I have a Barcelona folder. And I'm going to go ahead and open a pull request. basics.kids.io, CD contributor playground. All right, I'm already in the right. Sorry. Git demo. Right. So what this contributor playground repo is, it's really a way for people to safely figure out how the contributor automation works. What I'm going to do is do the same thing. I'm going to git fetch upstream, git rebase. And then I'm going to go, oops, I checked out before, so I'm going to rebase again. Demo. Cool. So now I'm in the demo folder, and I'm going to create a file in the Barcelona folder. I'm going to say, hi, new contributors. So what I'm doing right here is I'm just following the regular development workflow. It's a little bit easier because all of this is text files or markdown files, but that's OK. What I want to show you is how you can interact with the bot automation on the contributor playground. The permissions on the contributor playground are a little bit different because it's meant to be a demo repository. Cool. I'm going to call it greetings. Oops, git add. I'm going to go hub pull request. Showing bot automation. Oops. I can vim in front of people. Really? OK. Insert. Interesting. What is happening? Why can't I do a pull request? Oh, because I didn't make a branch. Git push u origin demo. Sweet. OK. Now I should be able to do it. Yes! None of you stepped in to help me, by the way. Boo. I have weird aliases?
Yeah, I just do that to the web UI.
Oh, I really like the hub tool. Sorry. Let's go ahead and see what happened here. There is another pull request. Are we in Seattle or Barcelona? I don't know. Showing bot automation. Did I do this in the right folder? I really hope so. Let's find out. OK. What else changed? OK, so first of all, don't ever open a pull request like this one. No description provided. That's terrible. So I'm going to go ahead and notice that there are some labels already on the right-hand side. The green one, CNCF CLA, yes, that is the requirement, the base requirement that everyone needs in order to contribute to the project. If you are having trouble signing up for the CLA, we have a doc for that. It has a size label. This is really just to let your reviewer know how much work is going to be involved with reviewing. I didn't change a whole lot. The green approved label is just because I'm special, and I'm going to show you why. Because right here in the Barcelona folder, there is an owner's file. And this is the file where a lot of the reviewing automation lives. And individual reviewers and approvers, and we're going to talk about what that means in a hot second. Anyway, this is a list of people that have the authority to review and approve your pull request. Most pull requests in the Kubernetes community will need both an approval and a looks good to me, also known as LGTM. Again, just as I said earlier, come on, do the thing. Just as I said earlier, we can't just add a label. I can click on this. This is my own pull request. I can't click on any of this. So let's see what the bot says. This pull request is approved. That's just because I am me. This will not happen for most people. I can go ahead and say, this pull request has been approved, the full list of commands. This is going to get you back to the command help. And now if I want a reviewer, what's your GitHub? GV. I'm not sure if you're in the owner's file, but I can go ahead and try this. Sweet. That should work then. And so now let's see what happens. I have an assignee. Really cool. And you have a GitHub notification? I am surprised. So these are my GitHub notifications, just for funsies. Yeah, just looking at the left, I don't use GitHub notifications. This brings me to a point of struggle, again, in the Kubernetes project. Also, I work at GitHub, and I'm told internally that there is a team that is working really hard to make notifications a better experience for everybody. But in the meantime, my profile says, if you would like to get my attention, please ping me on Slack. Just because I am terrible at responding to notifications for the reason you just saw. And this may be the situation for a lot of your reviewers. So sometimes it will happen that the bot will suggest a reviewer to you, and they will not respond for a few days. So it is OK to try and hunt them down on Kubernetes Slack and say, hey, you know, I was wondering if you could help me with this. Be polite. Yeah, so now we have a comment. Can you please add a better description to your pull request? /hold. Now, you notice the bot added a label that says do not merge. The reason this is important is because as soon as a pull request has gathered all the labels it needs for approval, it will get auto-merged. There will be no merge button. There is no merge button. Notice the only thing that I can do is close the pull request. Can't merge. So Tide is the automation that will ultimately merge your pull request. So it's often really important if you're working on a pull request and you don't want it merged for whatever reason because you want one more person to take a look at it, you can hold your own PR using hold. If you want to cancel the hold, you can say hold cancel. All right. It is now time for you all to spam this pull request with some of the fun prow commands. I'm really looking forward to this.
Oh, yes, yes.
So SIG testing is a super fun SIG. And sometimes these work, and sometimes they're slow. Ooh, look, someone got a dog. I got a pony. There's also /meow. The cat plugin, I think there's a /bark as well for those of us who like dogs. I wonder if space pony works. Pony space. Oops, not pony space. Maybe pony space works. There's a person on, there's a space pony. Anyway, there's a person on SIG testing that makes ponies and makes all these pony plugins. Twilight Sparkle. This is an awesome question, and in fact, currently under discussion. We are trying really hard to strike a balance between being welcoming and giving people all the links they need. The bot will often talk to you too if your tests fail, and there have been pull requests where there's literally just like 10 bot messages in the beginning, and yeah, that can be really, really cluttery, but on the other hand, let's scroll back up. So the short answer is no. The long answer is sometimes the bot has like a details fold out, and it's always a kind of tight balance. How discoverable do we want things to be? Will people really look closely and see that little triangle? That sort of thing. Don't worry, on most PRs, people aren't going to spam your entire PR with space ponies. This is just for funsies, so that we can kind of show how the bot automation works. If you approve of this pull request, if you are a reviewer, you can use this command. Yes?
What's the difference between approve and looks good to me?
What is the difference between approve and looks good to me? This is a great question, and a lot of people will give different answers. Welcome to open source. My answer is, a looks good to me shows a detailed code review by someone who is familiar with the code and knows the code will work and has looked at it and checked it out and says, yes, this is great, it checks out, it's fine to merge. An approve is an approval by a code owner, meaning the approver will say, I am OK with this kind of change. I haven't really looked at the details. I trust the LGTM, but I agree that it is important, necessary, good, whichever, to have this in the code base. So something may be technically correct and have an LGTM on it, but an approver may come and say, I actually don't want to add this feature or sub-feature, or I don't want to enable this plug-in here. And then they will say, then an approver will say, as an approver, I'm going to explicitly hold this PR. I want to have more discussion about it, even if it is technically ready to go. So that's the difference. The reason this particular PR had already an approved label on it is because I'm a code owner of this repo. However, if I hit /LGTM, you all should get a /LGTM sticker, by the way. The bot will complain at me. Well, it should be yelling at me. Bot is being slow.
It just pops up for me. You should be able to refresh.
I'm refreshing, but it's taken a while. There we are. You cannot LGTM your own PR. However, if anyone else in the owner's file LGTMs me, then this can auto-merge.
You want me to?
Go for it. Yes?
So are the same bot commands used for all of the different cities and sections of Kubernetes?
Yes, yes. This bot automation is being used across the project. In core Kubernetes, in Kubernetes community, in test infra, yes. There's a big YAML file that lives in Kubernetes test infra, and a lot of different repos kind of enable them slightly differently. But this is the general rule of thumb gist of it, yes. Core Kubernetes has a couple extra ones that are release related and milestone related. Others have slightly different labels. There are repositories where you have to get 2 LGTMs because they just want that kind of a code review process. But the gist of it and the general mechanics work like this, yeah. All right, it is 1 o'clock, and you should all have lunch. So lunch is from 1 to 2. So we'll be back at 2 and open a pull request together. All right.